Welcome back, students. Okay, in this video, what we're going to look at is solving some slightly more challenging equations. Sometimes before we can use the process that we learned in the previous videos for solving, for example, 1, 2, and 3-step equations, we have to do a little bit of work first to get the equation ready to be solved using that method. So here's the general process for solving almost any linear equation. By almost, there are a couple of tricky little equations which we're not going to study this year that require some additional steps. But what you're going to learn here will be enough to solve any equations you see in year 9, and the vast majority of equations you would see, vast majority of linear equations you would see anywhere. Now, so far, what you've learned how to do is step 3. Given an equation, solve it by undoing, adding, and subtracting, then undoing, multiplying, dividing, and so on. But it turns out sometimes you have to do an additional step or two before you can do that. So what we're going to learn in this video is what to do if the unknown is on both sides of the equation. So here are two examples. Here's the difference with this equation compared to the ones we've done before. I've got a 5x on that side, but I've also got an x on the right-hand side. So the first thing we have to do whenever this happens is to get the x on only the left side or only the right side. So in this particular case, what I'm going to do is say if I've got 5x there and 3x there, I can basically use this idea. And the first thing I want to do is add or subtract. But what I'm going to add or subtract in this equation is I'm going to take away the 3x from both sides. 3x take 3x goes to 0. And 0 plus 8 is just 8. 5x take 3x is 2x. And then just copy down the minus 2. So notice I had an equation that had the x's on both sides. By subtracting 3x from both sides, I get a new equation where the x is on just one side. Now we know how to solve this. We've done similar ones in the previous videos. We add 2 to both sides, leaving just 2x. 8 plus 2 is 10, so 2x equals 10. And divide both sides by 2. And the answer is x equals 5. Okay, let's go ahead and check that. Now, in this case, we got to check that the left-hand side and the right-hand side both have the same value. So 5 times 5 is 25. 25 minus 2 is 23. 3 times 5 is 15. 15 plus 8 is also 23. So that does check. Now, could I have taken 5x from both sides? Well, the answer is yes. Nothing wrong with that, except 3x take 5x, you end up with a negative 2x. So there's nothing wrong with that, except the equation is just a little bit harder to solve. So in general, do whatever step you have to do and try to avoid negative coefficients if you can. Okay, looking at the second example, I've got a 4x on that side, I've got a 7x on that side. So I could subtract 7x from both sides, but 4x takes 7x is negative 3x. Still correct, but a little bit harder to solve. So what I'm going to do instead is take 4x from both sides. Now, if I'm going to do that, I end up with this subtract 3. So I prefer, as I've done in past videos, every time I see a subtraction, change it to add the negative. Those cross out, and that leaves me with negative 3 equals 7x take 4x is 3x plus 8. And once again, I've started with an equation that had the variable on both sides. After the first step, I now only have the variable on the right-hand side. Okay, we now have to undo adding and subtracting. So I take away 8. I take away 8. Oops, that wasn't done very well. Let's go ahead and put that a bit lower. That leaves me with 3x on that side. Negative 3 subtract 8 is negative 11. Now, once again, there's not a whole number that works here, but that's not a problem. I just divide both sides by 3. I'll put the x now on the left-hand side, and x equals negative 11 thirds, which is okay. Give that a tick. Or if you prefer, 3 goes into 11 3 times, remainder 2. You can turn it into a mixed number. In algebra, we often prefer to just keep our numbers as improper fractions. Now this one is going to be too hard to substitute back into there. Chances are we're going to make a mistake when we're checking it. So if you want to check it, just go back through your steps to see if you've made any mistakes. Okay, it's now time for you to try these two equations. Turn off the video, have a go, and check your answers once you've finished. Okay, welcome back, students. So once again, we've got the variable on both sides. I'm going to subtract 2y from both sides. I want to keep my coefficients on the variable or on the unknown positive. That crosses out. That's actually plus negative. 9y take 2y is 7y. Plus 8 equals negative 6. Subtract 8 from both sides. Minus 8. Minus 8. Those steps cancel out or end up just going to 0. 7y equals negative 6 subtract 8 is negative 14. Divide both sides by 7. And y is negative 2. Okay, let's see if that makes this equation true. 9 times negative 2 is negative 18. Negative 18 plus 8 is negative 10. So the left side evaluates to negative 10. 2 times negative 2 is negative 4. Negative 4 plus negative 6 is also negative 10. So that does give us that is the solution to the original equation. Okay, looking at the second one, now just a reminder, whenever you've got a variable with no coefficient, the coefficient is 1, so it never hurts to write that in. I'm going to change that to plus a negative. Okay, let's go ahead and subtract 1x from both sides. Subtract 1x from both sides. Those go to 0. That leaves me with negative 2 on the left. 5x take 1x is 4x plus 4. Now I've got to get the x by itself, so I subtract 4 from both sides. They cross out. That leaves just the 4x on the right. Negative 2 subtract 4 is negative 6. Divide both sides by 4. And again, I'll write the x on the left-hand side equals negative 6 over 4. Well, the first thing I have to do here is I can simplify that. 2 divides into 6 3 times. 2 divides into 4 twice. So a better answer is x equals negative 3 on 2. Or alternatively, you could turn it into a mixed number. 3 goes into 2 once. Remainder 1. And x equals negative 1.5. Again, it doesn't really matter if you leave it as an improper fraction or a mixed number. Most textbooks would leave this as an improper fraction. Because it's a fraction, I'm not going to try to substitute into that. That's getting a little bit too tricky for me. So the best way to check your work is just go through all your steps very carefully. Okay, so that's the next stage is we had to do one additional step before we could use AMIB. First thing we had to do in this case is to get the variable on just one side.